Jumbo. In this PowerPoint, we are carrying on from yesterday's notes where we went through questions 1 to 5 of your nuclear decay sheet, and we're looking at balancing relatively straightforward nuclear equations. You're giving all the information except one thing, and using some simple skills, you can get it nicely balanced. We're going to breeze through 1 to 5, and then we'll spend a little more time on 6 to 10. There are the steps. Maybe you memorized them, maybe you didn't, but I think once you see enough examples, you really don't need to memorize the steps. And let's see how we get on here. So we installed the 19 there, and then we said 19 on this side, and we need a number that when we add minus 1 to it equals 19. Common mistake is put 18, but if you check 18 minus 1 would be 17, so that's wrong. We have to go one bigger than 19, and that's the 20. Once we know it's 20, we know that's calcium, and a 42. 42 there, 0 and 42 balances out. This is beta decay or beta emission because the electron is produced. It's on the right side, it's given off. Next beast, we need that number, 94. And we say, okay, what's happened? Oh, we've given off an alpha particle. So in the bottom, this number drops by 2 to 92, which is uranium. And the top number drops by 4, and we get 235. And that's always true in alpha decay. Bottom number drops by 2, top by 4. Next beastie. Well, we got a 92 here, we got a 90 there, so it dropped by 2, top number dropped by 4. And that's what we were just talking about. And this also is alpha decay. Number 4, we go 1 and 1 is 2. We go 1 and 3 is 4. And we say, hey, that's helium. And we've stuck two hydrogens together, so that'd be like a form of nuclear fusion. Number 5, we're still rattling along. Now, quite often if we hit something with a neutron, all that happens is its mass goes up by 1. But in this case, we hit it with a neutron, its mass went up by 1, and then it split into other things. So we had 3 plus 0 there. Here's our equal sign with the arrow. And so we know we're going to need a 1 over here. And that's got to be hydrogen. Then we have 6 plus 1 is 7 here. 7 take away 4 is 3. And that is tritium. So those are the 5 we did yesterday, and we blasted through them. Now we'll take a little more time. Number 6. We look at this and we go, okay, let's start on the bottom numbers. 13 plus 2 is 15. That means this side is 15. Well, 15 minus 15 is 0. And once we know that's 0, we kind of have this question beat. It's going to be a neutron. That means there's going to be a 1 up here. But let's check it out and see why. 27 plus 4 is 31. Oh boy, that's not very good. Oh well. So left side's 31. And the right side is 31. And so 31 minus 30 is indeed 1, even with my bad printing. Number 7, same game. We've got beryllium, we're hitting it with a proton. 4 plus 1 is 5. So on this side, this has to total 5 as well. 5 minus 2 is 3. Almost blotted that out. There's a 3, so we know that's lithium. Now we go 9 plus 1 is 10. And so this side has to equal 10 fried noodles. And so we go 10 minus 4, and that's got to be 6. And you can check at the end. 4 and 1 is 5, 3 and 2 is 5. 9 and 1 is 10, 6 and 4 is 10. And we just looked up on the periodic table to see what lived at spot 3. Next one, they didn't give us a number, so we look it up, potassium 19. Okay, so we know left is 19, so we know the right has to be 19 as well, total. So we put a 19, so 9s are kind of a struggle. And so we go 19 minus 1 is 18. This is not an electron, this is a positron. So 1 and 18 equals 19, that's balanced. This side says 37. So this side, yikes, kind of near the top here. Hopefully you can see that. That is supposed to say 37. 37 minus 0 is 37. And what lives at spot 18 is indeed argon. Now the next one is the most exotic we have on this page, and of course, or on this sheet, and it says positron emission just because the positron's right. So next one has a lot going on, so this one you really want to pay attention to. First thing to notice is the blank is on the left. So that tells us start on the right side where we have all the information like a good detective. 56 plus 36 is 92. Over here it says 3 times 0. We have 3 neutrons. Each neutron has no nuclear charge. 3 times 0 is 0, so we don't care about it. So right here I write down 92. That means the total on the bottom here has to be 92 to the left of the arrow. Well, there's a 0. 92 minus 0 is 92, so it's uranium. Now, it gets a little more interesting on the right. Whoa, almost decent. If I look at this, I go 91, and I say, what do I do with this? Well, that's saying I don't have 1 neutron, I have 3 neutrons. Each neutron has a mass of 1, so if I have 3 neutrons, that's a mass of 3. 3 and 91 is 94. And by now, after years of math, you should know when you add 94, all you do is add 100 and take away 6. And so this has to equal, it's one of my better 2s, 236. Well, that means the left side has to equal 236. We get 1 from the neutron, so 236 take away 1, and we're 235, and it's now balanced. This should look familiar to you from the notes. Well, maybe not so familiar. This is an example of nuclear fission, something we'll talk about tomorrow in more detail. But fission involves taking a large atom, uranium is large for an atom, and you hit it with a slow-moving neutron, and it splits, and it can split in many different ways, and in this example it split into barium and krypton, which both happen to be radioactive, and they would go on to decay. And it freed up neutrons, and hey, neutrons could go on and fission other things. Now some of you are saying, hey, we got 3 neutrons there, 1 neutron there. Can't we just cancel them out? And in a way you could. But this neutron is essential for making fission happen. So it's customary to keep that neutron in there because it's the trigger. It's what's going to, or the bullet that's going to make it happen. So this is nuclear fission. And we do have to remember there's going to be a neutron on the left, and we'll see more about that tomorrow. The last example, this is number 10, and we see we got a big atom in uranium, and so what we've got is all the information left, so we'll start on there, and we will leave the right side to later because it's where the blank is. 92 plus 2 is 94. Boy, it's hard to draw 9s. This side has to be 94 as well. There's a 0. So 94 minus 0 is 94. A periodic table that says plutonium. And we look at up top. 238 plus 4 is 242. And that means we've got to make that 242. And we go 242 minus 1, so we better have a 241 there. So we've hit uranium with an alpha particle. And remember, when you're done, you can always check. 92 plus 2 is 94. 94 plus 0 is 94. Bottom number charges are balanced, nuclear charges. 238 plus 4 is the same as 241 plus 1. They both equal 242. As they say in Spanish, we is done.